So the last thing of week 3, water. So this is what we're going to do. 2 main objectives. We've got about 10 slides to go through. So water is really important, right? I've made the I don't know if joke's the right word, but I've made the analogy that we're essentially a walking bag of water that runs on electricity, and we're filled with some proteins. 50 to 60% of a person's weight is water. Fat-free mass holds on to more water than fat mass. But water is very important for a variety of reasons. One, it works in the cardiovascular system to form blood, right? Half of your blood is water, and that's our transportation system. It helps to regulate body temperature because as we sweat or as we redistribute blood flow, we can lose heat. And it also helps to maintain blood pressure, which is really important, especially during exercise. We need to maintain those pressures. So when it comes to water balance, it's a determinant of, this is a mass balance, right? We've talked about mass balance in class. The amount of water in your body at any one time is determined by how much are you taking in, how much are you losing. So at rest, we bring water in by drinking, we bring water in by eating food, and then there's also some formed when we form ATP. Okay, but we are also constantly losing water. So as you breathe, there's water evaporating from your skin. You have sweat loss. You pee most of it out. There's some with fecal, when you go to the bathroom, when you go to number 2. So that happens as well. And so if we want to maintain, we have to make sure that we bring in as much as we lose. Now, obviously, that's going to be difficult. It's not like you can calculate, I've lost 1.3 liters of water while breathing today. Now we can estimate it, but it's not necessarily easy. During exercise, things change, right? So notice this is what we did at rest, but now what happens, really what's going on during exercise is we're not bringing a whole lot in usually, but we're going to start losing a lot more from sweating. Notice that urination and fecal loss isn't on here because in a perfect world, that's not going on when you exercise, right? We actually reduce pressure to our kidneys a little bit so that we don't pee out all this extra water, even though pressure might be increased. And that's good because if we increase our urine volume while exercising, 1, we'd have to go to the bathroom, but 2, we would have our blood volume would decrease, and that would be hard to maintain pressure. So as you can see here, this is, kind of the same idea as the previous slides, but just giving you some specific values. Okay, so normally we lose about 15 milliliters of water through our skin every hour. Really what it is it's close to 100 mils per hour. But when it comes to exercise, that's it can be 1.3. Okay, so that's essentially that's a 1.25 liters more. All right. And so 1 liter of water weighs a kilogram. That's 2.2 pounds. Okay, so you lose 2.2 pounds of water during prolonged exercise if you exercise for an hour. And it's actually more than that. It's probably closer to about almost 2.5 to 3 liters, 2.5 to 3 pounds of water that you're losing during prolonged exercise. So what do you see as you go here, right? It's just a higher level. The skin's still losing the same amount. You're breathing more, so that increases, but your sweat is really where this changes. Notice that you don't lose any via urination or feces or very little. There's still water going to your kidneys and into your bladder, and once that fluid makes it to your bladder, it's essentially gone even if it is contained in your body. Okay, so what are some things you think could change these values? Now, dehydration can play a big issue or play a big role in performance here, okay? And so, and specifically endurance performance. It's not clear, though, how it will affect strength performance. And so what we've got here is we've got hydrated and we've got dehydrated. In this study, it was about 2% decrease in body weight, which for this was about 10% decrease in plasma volume. Okay, notice that the difference in performance. Okay, and so this is as they're basically doing a 10-kilometer race, and so how fast they're running after what is this? 1.5. So 1,500 meters, 5K, 10K. All right. Notice that there's a big difference, even from the beginning, in how fast they are running. And that's because of dehydration. Another thing that happens when you sweat is that's how you lose electrolytes. Okay, so Gatorade, one of their big things is that, hey, you'll replenish your electrolytes. And the main one that we lose is salt. Okay, sodium chloride. That's why salt or sweat tastes salty. Okay. Now, how much you lose is affected by all sorts of different things. Okay, so your genetics, how much you're actually sweating, how well trained you are, if you're acclimatized. Like, for example, we'll talk a little bit about this at the end of the semester, but if you're acclimatized to the heat, you actually sweat a more dilute sweat. In other words, there's less electrolytes in it. Okay, you'll sweat more, but you'll lose less of those electrolytes, and that's important. Okay, we can also lose these electrolytes via urination to help maintain homeostasis. As with just about anything, we don't want too many, we don't want too little, we want just right. All right, so as we've mentioned, and as you're aware, when you're exercising, though, generally you don't urinate as much, and so that helps reduce electrolyte loss. So in this case, if we're going to sweat, we're going to lose electrolytes. Well, what do? We need to, at least at the very minimum, replace the fluids that are lost. Okay, and so here again, we've got prolonged exercise, so 6 hours, right? So this is pretty low intensity, but it's a long exercise. And notice that this person doesn't take in any fluid, this person takes in saline, and then this person takes in water. Okay, and so there are benefits such as dehydration is reduced, core temperature is reduced, performance is also improved. Okay, but what are some issues if you drink too much? Okay, so just think about that. What would happen if you started drinking a lot of water, especially if you're drinking more water than you were actually losing? Okay, and so this can lead to something called hyponatremia. All right, and so what that means, hypo, low, natremia, we're talking about sodium concentration. So you have a lower than normal concentration of sodium. And there's really two ways that this can happen. One is you just don't take in very much salt. But the more common way for this to happen is you just drink a lot of water. Okay, and it is possible, I talk about this in my physiology class, it's actually possible to have, to die. Like, just to be blunt, for a person to die if they drink too much water. And what's happening is you've got so much water and it's so dilute is that water starts to enter the cells, which causes them to rupture. You can actually increase the size of your red blood cells so they can't enter the capillary. You can cause cerebral edema. Okay, none of these are good. And so, and the reason why is because we've reduced the concentration of salt on the outside, and so it can't pull fluid out of the cell. So how do we prevent this? Well, in a perfect world, you would, whatever you sweat out, you'd replace in fluid. So if you sweat out, a 3% solution of sodium chloride and you sweat a liter in an hour, you would drink a liter of 3% sodium every hour. But that's not possible. And the reason it's not possible is you can't handle it. Your stomach, you'll have GI issues. Okay, so sport drinks are actually more dilute than what you're losing, but it's better than nothing. And so as a result, and it's really difficult to design appropriate guidelines because one, everybody sweats at a different concentration. Two, you can't replace in the concentration that you lose. And so it can make it difficult. And part of it too would be that if you were trying to replace in the concentration you were losing, just think about the taste, right? You know how salty sweat can be. Like, are you going to want to go chug, a cup, half a cup, a tablespoon even of salt water? And so what are the recommendations for exercise is that a couple hours before your race, drink a fair amount of water. Half a liter is a decent amount. Okay, so that's 2 cups of water. This will help make sure that you're hydrated when you begin your exercise bout. And while you're exercising, try and drink enough so that you don't lose more than 2% of your body weight. Okay, again, that's going to be difficult to know because it's not like you're going to have a scale like you're in the middle of a marathon. You jump on a scale, you're like, oh, I've only lost 1%, I'm good. The thing you definitely don't want to do is you don't want to drink more than you're losing. In other words, you don't want to increase your body weight. And then afterwards, replace what you lost. Okay, and then you'll be back kind of in homeostasis. You might have to do some stuff with the ions you lost, but you'll at least be on the right path. And so that's how we're going to end week 3, talking about water.